Welcome back. Are you interested in learning more about Python and machine learning? Well, welcome back then. Last time we discussed about single loss full function that calculates the loss of the all the data points. Now we will create a function that updates the theta and theta naught based upon looking at one single data point. Let's do that, shall we? Here, let's begin by writing the function for perceptual single update. But before we do that, let's define what this function is. Let's go through the definition of this function. It properly updates the classification parameter theta and theta naught on single step of a perception algorithm. Arguments it takes are feature vector and numpy array describing a single data point, label, correct classification of the feature vector, current theta being used by perception algorithm before this update, current theta naught, the current theta naught being used by perception algorithm before this update. It returns a tuple where first element is a numpy array with value of the theta after the current update has been completed, and second element is a real valued number with value of theta naught after current update has been completed. So that's the definition of this function. Now let's start coding this function. Remember, we created a function called single hinge loss single. That function will be useful here. If hinge loss single feature vector label current theta current theta naught greater than 0. What he's saying is that, okay, I have this label, I have this current theta and theta naught, and I have this feature vector. Now I'm going to give that to the hinge loss single function, and it will tell me whether there is a loss or no. If loss is greater than 0, then I will update the theta and theta naught. That's what I'm doing. If loss is greater than 0, then I will update the current theta and theta naught. That's what I need to do, right? Because there's a loss there. Now what I'll write plus equal to label times feature vector. This will give me the new current theta if there's a loss, because we don't want any loss, so this will reduce the loss, right? And we'll also calculate new current theta naught plus or equal to label. This is our new theta naught. What we have is now current theta and theta naught consequently. Next step is return these values as a tuple. Current theta, current theta naught. Is that right? What do you think about this when you look at this code? We have these two part of the code. First is we are checking whether single hinge loss signal is greater than 0. If it's true, then we are updating current state or not. If that is not true, then we are bypassing the if part of the code and just returning current state or not as it was inputted to this function. Hence, this is our function. So in summary, what I want to say is that this function updates the current state or not based upon the loss of the particular data point. In this way, we are able to update, we are to change our linear classifier based upon the data we see each step, and it is mostly used for online training. That means, thank you so much.